The last lesson in Chapter 7.3 is going to be Day 3, Solving Translated Trig Equations. In this lesson, we'll take a look at a coefficient in front of our variable that we're solving, and this will give us more solutions or less solutions depending on the type of coefficient we're working with. It says solving equations of the form a sine bx equals 0. What I'd like you to do is actually replace x with theta. So I'd like this to read a times sine b theta equals 0. We haven't been solving for x, so let's stay consistent with a theta symbol. Back when we graphed trig equations, if b was in our equation, it was just a coefficient. When we graphed it with x, that helped us kind of determine the shape of our graph. When we solve it for theta, it's going to mean something as well. Back with graphing, if b was greater than 1, the graph would actually compress, which meant it shrunk kind of on the x-axis and crossed the x-axis more times. That will mean that we're going to get more solutions when we solve. If b is a fraction between 0 and 1, the graph would stretch. And if it stretches on the x-axis, it may not cross as many times, meaning there are going to be less solutions than normal. To solve, we're just going to follow some basic steps, and eventually we'll tie in to our rules from day 1. The first thing you want to do is isolate your sine b theta term, or whatever the trig term is. So it could be any trig term, like cosine, tangent, and so on. You want to isolate that term. Then you want to take the inverse to isolate the b times theta. If you have unit circle values, they must be exact, whether you're in degrees or radians. Now thinking about the number of solutions, this step gets kind of crazy. If b is greater than 1, we have to find b number of coterminal answers to step 2, and they need to all be positive. To get that, we'll either add 360 or you would add 2 pi, depending on if you're in degrees or radians. If b is between 0 and 1, so if b is a fraction, we can skip step 3 altogether. Last but not least, you still have to isolate theta, and to isolate theta, we'll divide by b. Now, what makes day 3 actually a little easier than days 1 and 2 is once you've taken the inverse in step 2, you don't have to do that process again. There won't be any factoring, we won't have to do quadratic formula, and we don't get to take the square root to solve. We'll just follow these 4 basic steps. And we'll make a couple of changes in the directions on the back as well if you printed off the notes. It says solve for values between 0 and 360. We're going to keep all of these in degree mode. And I think in the note packet originally I had this page in radians, but let's just keep it in degree mode. And that means we'll approximate our solutions to the nearest tenth of a degree when necessary. Make sure your calculators are in degree mode and we'll get started. Our first example, 2 times cosine 3 theta minus 1 equals 0. Notice nothing's being squared, and we've got a coefficient with our theta. So this is following day 3 exactly. To get the trig term by itself in step 1, you want to isolate all of this right here. That means we need to get rid of the 2 and we need to get rid of the negative 1. Thinking about order of operations backwards, we would actually move the negative 1 to the other side by adding it. That's the opposite operation, that cancels it out. We still have the 2 out in front of the cosine. So we'll get rid of that next. Divide both sides by 2. Leaving us with cosine 3 theta equals 1/2. There's step 1, isolating your trig b theta term. Step 2, take the inverse to get your b times theta by itself. So on the left side, you'd be left with 3 theta. On the right side, we have to take cosine inverse of 1/2. Recognizing that that is in fact on the unit circle, there are two answers, and we'll take them, that's an L, there we go, we'll take them in degree form. When does cosine equal positive 1/2? That would be at 60 degrees and at 300 degrees. That's when cosine equals positive 1/2. And then step 3, if b is greater than 1, we have to find that number of coterminal angles with our two answers in step 2. Well, look at this. b is 3. That means we have to have 3 pairs of coterminal angles with 60 and 300. So this is kind of crazy. What we'll do is we'll add 360 to 60 and we get 420. So we need another pair so that we have 3 sets total. We have to add 360 again, and that gives us 780. We'll do the same thing with 300. We're just getting sets of coterminal angles. If we add 360, we're at 660. And if we add 360 again, get that in there, we'd get 1,020. This means we're going to have 6 different angles that match up at the location for 60 and 300. All 6 of these are coterminal. What I'm going to do is just list them all out. 3 theta equals, we have 60 and 300. Then we have 420 and 660. Whoops, 60. There we go. And then 780 and 1,020. So we have 6 different answers, triple the amount of the normal answers because b is 3. Step 4, to get theta by itself, now is the easy part. Now all we're going to do is divide all of our answers by 3. And get this, when we're done, we're going to keep our restriction in mind. All of our final answers will be between 0 and 360 degrees. To get theta by itself, if we take 60 divided by 3, we have 20 degrees. 300 divided by 3 is 100 degrees. 420 divided by 3 is 140 degrees. 660 divided by 3, 220 degrees. 780 divided by 3, 260 degrees. And that big angle at the end, 1,020, when you divide by 3, actually becomes 340 degrees. 6 answers, you guys. That is crazy, but all between 0 and 360 degrees. For example B, I'd like you guys to do step 1 first. Isolate the trig term. That seems pretty easy. All I did was add 2 to move it to the other side. And now we have cosecant, so there's a reciprocal happening here. Step 2, to get b times theta by itself, we take the inverse. I'm going to write it out just kind of like the equation is as in the form it's currently in. If we take the inverse, we'll be left with 4 times theta on the left, and we would take cosecant inverse of 2. But we know cosecant isn't user-friendly on our circle. I'm going to keep my 4 theta on the left. I'm not changing that at all. And I'll do my inverse rule, or my reciprocal rule. Instead of cosecant, I'm going to do sine inverse. And instead of 2, we'll do 1/2. So I took the reciprocal of the trig term and the fraction. And now back to business as usual. We have 4 theta on the left. When does sine equal positive 1/2? That will be in quadrants 1 and 2 at 30 degrees and 150 degrees. Those will be the 2 unit circle values. B is 4, so this is our step 3. If B equals 4, that means we have to come up with 4 groups of coterminal values, so 4 sets total. And we'll add 360 to our original angles until we get 4 sets. I'll start with 30. If we add 360, that gives us 390. If we add 360 again, that gives us 750. So I've got 30, 390, 750. I need one more set for coterminal. 750 plus 360 would be 1,110. Do the same thing with 150. Add 360 first. That'll keep us in quadrant 2 at exactly 510. Add 360 again, and that puts us at 870. One more round for coterminal, add 360 to that, and we should get 1,230 degrees. That's a lot of angles to work with. Let's set 4 theta equal to all 8 of them. We have 30, 150, 390, and 510. 750, I might run out of room, 870. No worries, everybody. We can make the screen smaller. Look at us go. All right, that's enough. After 870, we have 1,110. 1,110. Oh, I can't get that to fit. Gave myself all that space. Oh, it's fine. 1,110. And then our final angle, 1,230. Now, as is, those are definitely way too big. They don't fit our restrictions at all. But remember, we've got to get theta by itself. From here, we'll divide all of these answers by 4. And when we do that, we are going to get decimals for this, but they will be exact answers to the nearest hundredth. They don't go any further than that. So they're still related to what we originally got on our unit circle. If I take from 30 to 1230, all divided by 4, I would get 7.5 degrees. And then we'd get 37.5. 390 divided by 4 would be 97.5. 510 divided by 4, 127.5. 750 divided by 4, 187.5. 870 divided by 4, 217.5. Whew, we're almost there. 1,110 divided by 4 would be 277.5. And our final answer for this one, 1,230 divided by 4 would be 307.5. And just like that, everybody, we have 8 answers within our restriction that make that equation a true statement. And I think we'll call that good for today. Tomorrow we'll do examples C and D, where we'll have decimal approximations, and then you'll have your worksheet.